Awesome. Okay, hello everybody again. Welcome back to the Concordium Educate Series. We are joined again by Dragos and a new guest speaker. We've got Dennis from Boosty Labs. He's the CTO there. And this is for workshop 6 out of 7. So this is the last, second last one, the penultimate one now. And this is going to be about X402 payments on Concordium. So you'll get an idea of AI agents making payments and the accountability behind that, and how to do X402 on Concordium, how it all works, why identity matters, and how to implement it all. We are going to start with Dragos, who will kick things off, do a bit of an intro to all this. I think reckon about half an hour or so, and then some questions. Drop any questions in the chat as always, and let us know right now where you guys are joining us from, so we can see how international it is, see which countries are here. And then Dennis will round it off at the end. And yeah, as always, keep the chat going with any questions. And I will hand over to Dragos now.
Thank you for the introduction, Giles. Hello, everyone. Welcome to the 6th workshop. Today, we will be discussing X402 on Concordium. So, what we're going to cover today, first of all, we'll do a bit of a history overview. So we'll discuss about the missing payment layer and the HTTP 402 status code, which has been reserved for 29 years so far. And we'll try to figure out why the web never got native payments. Then we'll talk about X402 itself. We'll explain how it works, the protocol, the facilitator, and the flow of everything, who's using it, and how does it look like for developers, and we'll discuss the payment schemas. Then we'll talk about how Concordium fits into all this and Concordium and X402 as an integration. It's all about how identity changes the picture for X402, and we'll discuss a bit about the Agentic payments landscape. And at the end, there will be a guest speaker from Boosty Labs discussing X402 in practice and how that was actually developed and implemented. All right, so the missing payment layer. Let's have a look first as a small recap of the Concordium PayFi stack so far. So at the bottom, we have the identity layer, which is the chain itself. Then protocol level tokens, verify and access, and sponsor transactions, all built into verify and pay with sponsorship. Now, today, we will add the top layer, which is going to be X402 agentic payments. Thing is, initially, the internet was built without a payment layer. So the hypertext transfer protocol, HTTP for short, has status code for basically everything you would need in a working web application. So you have the basics like, OK, created to 200, 201, but then you see a missing spot between 401 and 403. That's because the 402 status code is currently reserved for future use and has been sitting empty since 1997. Now, why that is? Let's talk a bit about the history. So in 1997, HTTP gets a payment status code in RFC 2068. That's called request for comments. It's basically just a standard document that defines how the internet works. And that defines HTTP 402 as the status code called payment required. Initially, this was intended for digital cash systems. So during the dot-com boom, you had DigiCash, CyberCash, and Millicent. Back then, the dot-com boom was in full swing, and everyone assumed the web will have native payments. Now, between 2000 and 2001, the dot-com bubble burst, which means that all 3 digital cash companies folded during the crash. So DigiCash went through a bankruptcy in 1998, CyberCash was acquired and then shut down, and Millicent never reached commercial adoption and it quietly disappeared in the late 90s. Which means that no payment rail survived to actually use the status code. Now, around the same time, so in 1998, PayPal was created, and the web's payment model became credit cards and PayPal, not protocol level payments. And 402 as a status code was left with no implementation. Then in 2014, HTTP got another major spec update. This basically just updated the semantics. So it actually called 402 as a reserved for future use status code. So nothing really changed. Then in 2015, the World Wide Web Consortium, which is basically the organization that maintains all of the web standards, launched Web Payments Working Group. That's a separate thing, though, as they deliberately sidestepped 402, and they built the payment request API instead. So there was still no native payment layer in HTTP itself. Getting close to now, in 2020, Lightning Labs shipped L402. This was the first real attempt to actually use the 402 status code for payments. But the thing is, it paired the status code with the Bitcoin Lightning Network, but it never left the actual Bitcoin ecosystem. So settlement worked, but only with the Bitcoin Lightning Network. Now, in 2022, the current HTTP spec was published, and 402 was still reserved for future use. And then we had the big change in 2025 when, in May, Coinbase launched X402. And then, actually, at the start of this month, it went under the Linux Foundation. Now, let's try to figure out why it never worked so far. So the thing is, credit card economics basically killed micropayments. So most credit card companies charge somewhere around 50 cents plus 2.9% per transaction, which means that anything under above $5 is not really worth it at scale. Because you have the 30 cents, that's basically what, around 6% plus 2.9, you're already paying almost 10% to the credit card companies. Another aspect is that browsers never build a native payment UI. So that means that there was no incentive without an actual payment rail that worked and was already there. And before stablecoins, there was no global settlement currency. So there was no digital currency that moved in seconds at actually acceptable fees, which means that in the end, the web defaulted to ads, subscription, and paywalls, and payment was left to happen at the application layer, so not at the protocol layer itself. Now, what has changed since then? So we had three big things happening at once. First of all, stablecoins. Those provided a settlement currency that actually works at a global level. As of 2026, as of now, there's over $300 billion in stablecoin value. Then we had actual real blockchain finality in seconds, which makes real-time payments practical again. And now in the later years, we had this whole AI boom, which means that with AI agents, the agents will need to pay for services programmatically. Because the thing is, first of all, I don't think you would want to trust your credit card information to an AI agent necessarily. But even if you would, an agent still can't fill out a checkout form or enter a credit card number, and it would need an HTTP native way to pay, so something at the protocol layer itself. All of these things coming together means that the conditions that were missing in 1997 now exists, and X402 is the protocol that fills that gap. Now, let's do a deep dive into the protocol itself. So, what is it? First of all, if you scan the QR code in the bottom right, that will take you to the GitHub repository, where you can actually have a look at the entire code itself. As when this was originally published by Coinbase in May of 2025, it was open source from day one under the Apache 2.0 license. You can see the authors of the original white paper there. And since April 2nd, 2026, there has been quite an interesting development as the entire X402 stack is now governed by the Linux Foundation. The founding members, among others, were Cloudflare, Stripe, and Shopify and Circle. The very important bit that you need to remember about X402 is that there is no token that's required for it. There's no account required. It's just basic HTTP headers and then settlement in stablecoins. Now, let's have a bit of a look at how this all works. So here we have an example just for demonstration purposes. So this wouldn't be real endpoints, but let's say that a client is going to request a research, which is normally behind the paywall. So the client will do a GET request to, let's say, an API asking for weather. If payment is necessary, then the server will return HTTP 402 as a response with all of the payment details in the header. So you have the price, the token, and the address to pay to. Next step would be that the client will call the endpoint again, but this time he will resend the request with the payment signature in the X payment header. So first the client would sign a stablecoin payment and then call the endpoint again, but now the header would be filled with the actual signature of the payment. At the end, there would be a lot of verification happening at the facilitator level. And in the end, the client, if everything went through, would respond with a normal 200 OK and actually send the resource. Now, the cool thing about all of this is that there has been no prior registration happening, no API key usage needed, no authentication, no subscription. You don't have to go through all of the complicated billing process, and the payment itself is the actual authentication. Now, let's talk a bit about the facilitator. So you've seen that that's quite an important part in the flow itself, and this is actually the central piece of X402. This sits between the resource server and the chain itself. So what this does is it verifies the payment signature. It then broadcasts the transaction on chain, pays the gas on behalf of the payer. Now this would reduce a bunch of the friction because then the payer only needs to hold one type of token. The facilitator will then wait for confirmation. And at the end, if the confirmation comes through, we'll return a settlement receipt to the server. So the way it works in the header, when you get the last response, there will be basically a transaction hash that you can consider as your receipt. As an example, just the Coinbase hosted facilitator, for example, is free up to 1,000 transactions a month and then costs 1/10 of a cent beyond that. But the cool thing about this is that anyone can actually run a facilitator. So this is all open source. This is not, you don't need to use a specific one. Now, let's have a short look at a bit of actual code. So this again is just for demonstration purposes, but let's say you would want to implement this on the server side. You would have basically just around 3 lines of middleware. So your app would use some payment middleware. Then you would specify the route. In this case, it would be from the previous example, get and weather. The price would be the price which you would want to ask for that resource, the network, the network and the chain that it uses, and the address to actually pay to. And then you would specify the facilitator URL, and the facilitator would take care of everything else. So this is quite easy to implement, especially if you compare it to managing subscriptions or billing or API keys. If you've developed web apps before, you know that maybe the code itself is on the hardest bit, but then having to get the contracts and start the discussions in order to have all of the subscriptions for payments, that takes quite a while, and it's a bit of friction in the development process. Now, on the client side, the wallet or agent will just sign a type data message. So, for example, on EVM chains, this is under the EIP 712 standard. The facilitator will handle all of the gas and settlement, so the client doesn't have to worry about that. And again, the developer doesn't have to manage any subscriptions. For SDKs, you could use for this just the basic examples, TypeScript, Python, Go, or Java. And for middleware, you can basically use anything. I put Express there as an example. Now, X402 supported chains. So the Coinbase hosted facilitator is on Base, Polygon, and Solana, but the full CIP2 spec also covers a bunch of other chains like Ethereum, Arbitrum, or Optimism. And on Concordium, the facilitator is via Boosty Labs. Now, if you have a look at the chain identifiers, those all use the CIP2 format, and you have some examples of how it looks on different chains. All right, now the payment schemas. These are quite an important bit of the X402 architecture itself. So what we have so far, we have the exact scheme. This is the default and the most widely used one. It's a fixed price per request. It uses, for example, EIP 3009 transfer rate authorization for USDC and EuroC that would be on EVM. What this means is the very simple scenario where the user signs, the facilitator will submit, user will pay 0 gas in the native token. So you're just asking for a resource at an exact price, basically. Then you have the up-to scheme. This was shipped in early 2026. This is used for usage-based billing. So you would set a maximum and then only pay for what is actually consumed. The best use case to think of for this would be LLM token metering or any kind of variable APIs that you will need to use. And just as a note, there is the deferred scheme. This has been proposed by Cloudflare, but it wasn't actually yet finalized. This would be used for batch settlements, for subscriptions, and aggregated payments. Now let's have a bit of a look at the timeline for X402 adoption. So in May 2025, as I've mentioned, the white paper was published. The protocol was open source from the get-go. Then in October, transaction volume was up by more than 10,000% in just 4 weeks. So it started getting traction. And by December 2025, there have already been more than 100 million cumulative payments. And the latest development was that on April 2nd, the Linux Foundation takes governance of X402. As some examples of production APIs already accepting it, you have Fireclaw or CoinGecko, among others. And for some notable integrations, Stripe has launched an X402 preview on February 10, and Cloudflare is shipping X402 support through its Agents SDK. Now, we've explained what X402 is. We had a bit of a history look. Now let's talk about how Concordium fits into all that. So first of all, what's missing in X402 itself? All it does is it handles pricing and settlement. But this is very important. It doesn't handle identity at all, which means that if a service needs to verify age, jurisdiction, or accreditation before completing a sale, the developer has to build that separately on most of the chains that X402 is implemented on. Now, there is no protocol level identity integrated into X402. So the verification is always an application layer add-on. So it adds friction in the development process. And if you want to actually have this in a production environment, regulated and compliant at scale, you would need to have it as an add-on, which would mean that every implementation is different, fragmented, and inconsistent. So by comparison with the rest of the market, on Concordium, identity verification is built into the protocol itself, which means that it can pair very nicely with X402. So the integration has been announced in December of 2025, and it's built by ecosystem partner Boosty Labs. For the separation of concerns, what happens is that X402 owns pricing, payment requests, and settlements, whereas the Concordium chain itself owns identity verification and stablecoin rails through protocol level tokens, and sponsored transactions, which we discussed at scale in the previous workshop, will let the facilitator cover the CCD fees. Neither system needs to know about the other's internal, and the facilitator is basically the bridge between the two. Now, let's have a look at the flow of how this all works in practice. So you would have a client. This could be either a normal user or an AI agent. They would go ahead and call a resource server. So for example, this could be a wine shop, which in a bunch of countries would have to be age-gated. The X402 middleware would be implemented there. And then the resource server would basically respond with HTTP 402, mention the payment is required, and it would be 10 euros for a bottle of wine, let's say. But at the same time, the client would have to prove that either the person behind the AI agent or the person itself is above the age of 18. What happens next is that the client will generate both a zero knowledge proof and the PLT payment. the sponsor would be paying the CCD fee, the server would verify the zero knowledge proof, and then the facilitator will verify all of the transaction parameters and then would settle the PLT payment itself, also paying the CCD fee by the sponsor. At the end, the client will get back a 200 OK response. The resource, in this case, just the bill that you would get from buying something would be delivered along with the transaction hash. And the really important thing about this and the cool part of it is that payment and identity verification is all happening in one HTTP request cycle with no personal information about the user ever being stored by the merchant. Then there is no separate KYC flow. So X402 handles the pricing and the settlement, whereas Concordium handles identity, and the facilitator is a bridge between the two. Now, just a bit of a short mention. In the last workshop, we discussed all about sponsored transactions, and now you can see how this actually all fits in practice. So before Protocol 10, users and agents would have needed to pay the CCD gas fees, and holding only stablecoins wasn't enough. But at this point, the facilitator can act as the sponsor, cover the CCD fee at the protocol level, which means no extra token custody, no smart contract intermediaries needed in the middle, and the agent or user would only hold stablecoins. So the X402 facilitator manages the entire flow, what the payment is for, the amount, and the sponsorship. The transaction itself uses stablecoins, while the facilitator will cover the CCD fee. So how this all makes Concordium shine? On other chains, facilitators have to rely on smart contract delegation and token approvals. Identity is always an application layer head-on, so it's harder from the developer's point of view, from the merchant's point of view, and then also from the user's point of view, because it's extra steps and extra processes, which don't have to happen. Whereas on Concordium, the facilitator will sponsor at the protocol level without custody. The identity is the chain itself, not a third-party service. And zero-knowledge proofs work for both humans and agents acting on behalf of verified humans. This means that self-custody is preserved throughout the entire flow. Now we're getting close to the end here, so let's have a look at the agentic payment landscape. So Concordium's approach to agent registry. Agents registry, there will be agents registered on chain linked to verify humans via Concordium ID. Protocol level locks with something on the roadmap that will be happening, which means that there could be spending caps, for example, set on agents. And then you have MCP servers, which would mean that agents could discover Concordium tools natively. How other chains are approaching the same problems? We have on Ethereum trustlet agents, and Google has the agents payment protocol from April 2026, which is just an authorization layer with signed mandates. The differentiator with Concordium is that there's mandatory verified human identity behind every agent. So it's a risk that's going to be happening with all of the AI agents actually being open in the market now. You wouldn't want anyone just being able to go ahead and buy anything on the internet without knowing that there's an actual person behind the AI. All of that exemplified in a figure. So you have X402 settlements. That's all done through sponsored transaction, agent communications, and the Concordium identity layer is the base of everything. As I've mentioned before, for the agent roadmap, there will be an agents registry, then protocol level locks, and in the second half of 2026, MCP and A2A servers. Those would be official Concordium servers that would expose PLTs and protocol level locks to any LLM agent. Now, thank you for your attention so far. I will wait for a minute to see if there are any questions before proceeding to the demo. Seems no questions so far. All right. Thank you, everyone. Then I can hand off to Dennis from Boosty Labs to discuss how X402 was actually built on Concordium.
Thank you, Dragon. Let me then share my part of presentation, and I will explain in details how we achieved this integration and actually how you guys can use it in your real development experience. All right, let's get started. Yeah. So before we move to concrete implementation, let me just give you a couple of words about who are we. So actually we are a development firm that has 150 plus engineers, and basically what we do full stack Web3 development. Among our partners, such great names as Concordium, of course, Stellar, Casper, The Graph, and many others. So we are working with such clients as Ledger, Coinbase, MoonPay, OneInch, and yeah, that's a really long list of what we can do and who we are working with. But let's get back to our Concordium integration and X402. As Dragon mentioned it, we have built full facilitator implementation, and that includes, of course, zero knowledge proofs, identities, and protocol layer. What we do with our facilitator, we do stablecoin payments, and the essential part of this protocol is that we do sponsored transactions. So that's super important because actually that's a way how this protocol works. So you cannot actually build transaction and propagate it from your own wallet or your own client application. You are required to send it to facilitator, because facilitator is a thing that not only propagates the transaction, it also checks and verifies that you have everything correct within your transaction. So that is super important to know. All right, so let's repeat a little bit how it works from architectural perspective. So again, from developer's experience, you have two sides. Basically, the first side is client application. So for example, if you would like to build an application that connects to some resource server that has this feature enabled, then basically what you need to do on client side, you need to build transactions there. So that's first important step. Then if you are building resource server, on other hand, you need to actually enable this feature for your endpoints. So here in this whole architecture, we are talking only about HTTPS REST APIs. So this only works with REST API, right? Because it's built on top of HTTP protocol. So all you need to do, you need to just enable it with almost one line of code. For example, if you're building on TypeScript, you will need to add middleware and provide your payment details. So pretty much that's it. So you provide payment details, you provide how much you would like to charge for the specific resource, and starting from there, you can build your own API monetization services. So then it comes our facilitator. So for each chain, for X402, you cannot do anything if you don't have facilitator, right? So that's a key thing, key breach in this architecture, because it accepts transactions from your resource servers, validates it, and propagates to network. You don't need to build any new facilitator. You don't even need to host it because it's provided by ecosystem itself, right? But it's just good to know what would be internals of this server. So basically for facilitator, essentially you have two methods exposed. The first method is called verify, and the second one is called settle. So from like outside, you can see only those two methods. And those methods are used by middleware. So you don't need to call them manually. You don't need to interact with them. It's all done by middleware. And basically, once you are building your new resource server, you connect middleware and you're starting working with facilitator directly. So that's how it works. And of course, here we need Concordium node, so you can actually settle transactions. That should be obvious. And the good thing for all this integration is that we are decoupling your resource servers from working with protocol layer and with network layer. So you don't need to interact with Concordium node. It's all done by Facilitator. So simply saying, if you are not Web3 native, you can still build Web3 applications using X402, and it's super easy because you are really abstracted from different blockchain internals, right? And the only thing you need to know is how to connect middleware. So that is the beauty of X402 protocol. That's super simple, super convenient, and what you can do, you can connect in minutes to any REST HTTP API, and that's it, and start working on it, right? So actually, from implementation perspective, typically client side has more work to do, because there you need to construct transaction, you need to send request, you need to resend request. So there you have a little bit more work comparing to what you have actually on resource server side. So that's how it works. Yeah, let's continue with payment flow. So basically, what you can do, you can start your client application by building. I'm sorry, I have some troubles with my microphone. So yeah. So basically, what you would need to do, you would need to send GET request to your resource server, compose transaction, make sure that you are building everything with your transaction details. And from construction, you need to send this request to your resource server. Basically, then through middleware, payment is settled to Facilitator, and that's basically how it works. So I will continue with actual demo after I will explain a little bit more details about how it works. So you don't need gas token, as Dragon mentioned it. You can settle payments in stablecoins. You can build machine-to-machine communication, and that's super important because that's not only for UI, it's also for machine-to-machine communication. So basically, you can build your own agent that will go to any resource server, pay for data it needed, and build your data integrations. So that's also a super important takeaway from this integration. All right, I will now stop sharing my presentation and share you first demo videos that I have prepared for us today, and I will demonstrate how it works with UI for first part. All right, so actually for this integration, we built demo applications that can demonstrate you how to work with X402 protocol and how to build your own applications. So in our case, what we do, we connect our wallet to our demo application. That's the first step. So we making sure that we have all of the details, we have account, and we have our identity that we will attach to our request. So as you can see, here is our age, and during our communication process, we will generate proof and actually sign this transaction as a part of our communication with resource server. We do it now. So we have everything for our transaction to be built. So the next step would be to send this payload to our resource server. So as you can see, here is our signature that we will pass as a header to our resource server. So from protocol perspective, what you need to do, you need to set X payment header in your GET request, and we will do this with the signature. And after you will specify all of the data, basically you can proceed with getting data from your resource server. So that's how it works. you provide all of the necessary details, you pass signature and everything in header in your GET request, and in return you will get actually data from your server. So as a response from server, you will get transaction hash, so you can verify that your payment was broadcasted, and you can take a look, for example, to verify in your wallet that you have this transaction in your history. So that's obvious because we do settlement via Facilitator. And after it, you will receive access to the data. So in our case, our demo resource server will return you link to YouTube video. So that's how it works from UI perspective. That's the first part of demo. Let me actually share you the second part. So the second part would be for those people who would like to build actually machine-to-machine communication. So again, in this scenario, we operate with programmatic access. So now I will share what we are doing in this case. And for this particular case, we will demonstrate two scenarios. Scenario how you can pay with CCD token if you have some, and the second one would be with PLT tokens. So for demo application, we are running basically script, and this would be a script that you can use to build your own applications later on, right? So you can reuse it, you can extend it, you can build on top of it. And what it does, it works in the same way as you saw it in UI. So again, your application will require some resource. On step 1, you will get 402 payment required error, right? You do the exact same thing. You construct the transaction programmatically, you build and sign it, and then you are retrying with X payment header. That's how it works, right? In the same way. So you do the same thing with UI basically under the hood. But here you will do that just with your script. And then it works in a similar way. So you've got a transaction that describes how it works with CCD token. And then the second scenario would be to run it via PLT tokens. So again, nothing dramatic here. As you can see, we have changed our asset from CCD to, as you can see here, we have PLT tokens, and it works in exact same way, right? So again, you can take a look into transaction details if you want to verify that your transaction was settled. And then what you will have as a result, you will have access to your data. So yeah, that's pretty much it. That's how this integration works. So if you have any questions, would be happy to answer you and give you more details on how it works internally or how you can build on top of X402 integration with Concordium. So thank you, everyone. Dragon, back to you.
Thank you, Dennis. That was a great demo.
Awesome. Yeah, thank you very much, Dennis, for that. If anyone got more questions, then yeah, check them in the chat. I don't know if Dragos, are you going to say anything, or have you got anything else? No, awesome. Okay, cool. Yeah, a very good, another good workshop. That was the penultimate one. So we have one more now, the home straight for all you guys, and we've had very good retention and very good turnout with this Educate series. Make sure you keep that up, because that all goes towards your certification and your graduation at the end of this series, where you will get your certificate, which you can share on LinkedIn. You can put it on your CV and all of this. So make sure you turn up to next week's session, which is same time again. It is Tuesday at 4 p.m. BST. Oh, actually, sorry, it's a 1 hour earlier. So make sure you note that it starts at 4 p.m. So today started at 5 p.m. 1 hour earlier, it's at 4 p.m. BST instead of 5 p.m. next week on Tuesday. And this is Advanced Technical Concepts with Daniel and Torben, who are from the science department at Concordium. And it will be a bit more of an advanced technical session. examining the scientific and architectural concepts that underpin the Concordium blockchain. So should be another interesting workshop then. Make sure you turn up to that. And then after that last session, certificates will be sorted and handed out, and should all be a good end to this series. So as ever, keep the Discord going. Any questions, chuck it on there, and I will add the slides from today as well if Dragos will send them to me later, and I will get them on the Discord for you. And the recording from this from today will be up in the next hour or so as well. Awesome. Okay. Thank you very much to the two speakers today, and I look forward to seeing you guys again 1 hour earlier next week. All right. Thank you, guys. Bye.
Thank you, everyone.